Okay, number 3. First of all, let's go back to geometry. What is the formula for area of a triangle? Area equals
1/2 base times height.
1/2 BH. Okay, so now let's fill in the stuff that they tell us. What is the area?
20.
It's 20. We actually know the answer. It's 20. Well, we don't know the answer. We know the area. Equals 1/2 times. What's the base of the triangle?
X plus 2.
X plus 2. Times the height of the triangle.
1/2 base.
1/2 x. This is actually a really good ACT review. As juniors next year, most of you will be taking the ACT, and there's all kinds of area and geometric stuff applied towards algebra. So this is a perfect example of something you might see on the ACT. So now, let's go ahead and, distribute the 1/2. So that just ends up being 1/2 x plus 1 equals, and there's a 20 on the left side. Now I'm going to keep this in parentheses still, because we still need to multiply that by the height, which is 1/2 x.
Do you not multiply the 1/2 with the second?
We're going to in a second. But to distribute 1/2, you only distribute it through the first set of parentheses. Now that it's in the first set of parentheses, now this looks like the parentheses are kind of deceiving, right? We really don't need parentheses here, because it's just one thing. So really, we just need to distribute again.
The 1/2.
The 1/2 x. So hang on with me here, you're going to have to do some fractions. What's 1/2 times 1/2? 1/4. Numerator times numerator, denominator times denominator. But I have an x and I multiply it by an x. X squared. And then this one here was 1/2 x times 1, so that was just 1/2 x. Yeah, we need to get set equal to 0. So I'm going to subtract this 20 over to the right side. So now we have 0 equals 1/4 x squared plus 1/2 x minus 20. Is A. I know you don't have a ton of room, sorry. A equals 1/4. And just for the sake of ease of typing it into the calculator, I'm going to call that 0.25. What is B?
0.5.
1/2, or I'm going to call it 0.5 so it's easier to type in the calculator. We don't have to deal with fractions. And what is C? Negative 20. See if you can take a second and quadratic formulize.
With the 2025, whenever I put this in,
if we go back to our original problem, we know we have two answers, 8 and negative 10. But if you go back and look at the picture, if I plug negative 10 in, is it possible to have a base of negative 8?
No.
No. So in real life applications, only one of the answers is going to make sense. Okay? So what is the only answer?
8.
Yeah, don't put negative 10 in your answer. The only answer that makes sense to the area of a triangle is 8. Now in this formula, T, what does T stand for?
Time.
T is time. V sub 0 is what we call the initial velocity. In other words, what's the velocity when time is 0? It's how fast something is starting, or the velocity of something. And then h sub 0 is initial height. So like if something starts on top of a platform that's 10 feet tall, I would plug in 10 for h sub 0. What's the height that it starts at? Which graphically is going to be the y-intercept, right? So like if I have a projectile that's it starts at a 10-foot platform and gets launched and then comes down, that is the c value of the quadratic. That's always going to be the y-intercept in standard form. All right, so let's take a look at the scenario that they give us and fill in the numbers. So we're going to write this as f of t equals negative 16t squared. And then what's the initial velocity of this object?
64.
64. So plus 64t. T is no different than any variable. You can put x's if you want. They just use t because we're talking about time and height. And then plus, what's the initial height of the object? 80. So this is the quadratic that we're working with here. That is actually, that's your answer for this one here. That is the model that represents the height. So if I were to give you t is 5, after 5 seconds, how could you find the height? Plug it in for t, and whatever answer you get, that's how high the object is at t seconds. Okay, so for the first part of this, what is the maximum height? Yeah, Seal. Okay, I'm going to graph this kind of over here to the side here. What's the initial height? 80. 80. So we have an object up on a platform, and no time has passed yet, so time is 0. And then it's launched up into the air, and then ultimately it's going to come down and hit the ground, right? Why does this part of the parabola not matter?
Because it's negative.
Yeah, we don't have negative time. So we just start at time is 0, that's the y-intercept. It's going to go up, and then it's going to come down and hit the ground, okay? So how many seconds until the maximum height is reached? Which axis is seconds? The y-axis or the x-axis?
X-axis.
The x. And the time when it's at its max has a special name. It's called the AOS. AOS equals, this is a good review from your first test, negative b over 2a. Go ahead and plug that in real quick. Do negative b over 2a and come up with the equation of the AOS. It'll be x equals, or sorry, I should say t, because we're talking about time. T equals the number that you get from negative b over 2a. So time is 2. That is correct. That means the vertex is 2, comma. Now they want to know what is the actual height. So when t is, now that we know t, when t is 2, how high up in the air is this object? So how can we figure that out? Plug in
Plug 2.
2. Plug in 2. So now go back into the original function. You can type it into your calculator if you want. Plug in 2 for all of the t's.
I put the exact same thing.
So it's right here. This is what I plugged into the calculator. Negative 16 times 2 squared plus 64 times 2 plus 80.
I didn't do it.
So where on this picture that I drew is this answer? If you had to describe it to me, where's that answer at? It's this x-intercept, right? And how do we find x-intercepts?
Calculator.
And the first half of this test, I showed you how to do it on the calculator. You did second trace, zeros, and then you did left, right, guess in the middle. Remember doing that?
Yeah.
Okay, but now we have to do it algebraically. This half of the test is solving quadratics algebraically. So what do you think is going to be the easiest way to solve this quadratic? Because remember, the solutions are the x-intercepts.
Bottoms up.
Yeah.
Bottoms up.
You can do bottoms up if you want, but I don't really want to multiply negative 16 times 80 and find the factors of that to add up to 64. Now, it might not be that bad. We could do GCF, but real life application, I'm just going to go ahead and use the quadratic formula. Okay, so let's go x equals negative 64 plus or minus the square root of, what is b? B squared minus 4 times a is negative 16 for gravity. And what was c? What was the height of the platform? 80. All over 2 times negative 16. Okay, go ahead and practice simplifying the quadratic formula, find the discriminant, take the square root of it, do plus or minus, and come up. I want, does this come out pretty? So the discriminant, square roots to 96. Now this is where I would use the calculator cheat code that I showed you to type in fractions. Math right up. So I'm going to do the plus first, negative 16 plus 96, all over negative 32. And let's go ahead and get decimal. Decimal makes more sense for time, right? So how do I turn a fraction into a decimal if you don't know what negative 5/2 is?
You do the second math.
Not second math, it's just math.
Sorry.
Math 2. So x equals negative 2.5. That's one of my answers. But now I need to go back, and in my calculator, I'm going to hit, or I guess I'll just retype it. So math right up, enter. Now I need to do the minus version. Oh crap, I didn't do that right, did I?
No, you didn't.
Why didn't you tell me that? I didn't see it was a 16.
I was like, how
Sorry.
did you get
Math right up, negative 64. There we go. Plus 96. All over 32. Enter.
All over negative 32.
So x equals 1. Did I do it wrong again?
Yes.
Yeah.
Oh my gosh. Okay,
Hey,
so,
start.
so it's negative 1, right?
Yeah.
I'll get it right eventually. And then I'm going to do second enter. I'm going to change this to a minus sign. I know.
5.
5. So we get negative 1 and we get 5. Go back to the picture I drew. Which one doesn't make sense? Negative 1. So when did the object finally hit the ground?
5 seconds.
5 seconds. That is your answer for this question.